Hi, I'm John. I'm going to go over how the concept of force relates to plant physical structure, specifically how mass damping within plants provides a force of compensating for mechanical stresses like wind. I mean, it's just basic physics. We all know that for every action there's a equal or greater reaction, and if it wasn't for gravity, we'd be able to see the transfer of kinetic energy much more easily. So I've set up here a demonstration, hoping to show you how two different plants, one with more mass and more distribution of mass, is able to react to force, in this case me, relative to a plant with a lot less mass and that mass also being equally poorly distributed across the plant. So I'm going to shake these plants simultaneously. And as you can see, this plant moved back much more quickly. It was much more whip-like, whereas the energy in this plant was distributed over time and spatially throughout the plant much more evenly. And that's a factor of there being weight and volume throughout this plant to be able to disperse that energy. And that's the mass damping effect. Essentially, that even if the stress is occurring here, you have the compensation occurring in other parts of the plant. And you can imagine that if these plants had a little bit more density to them and their cell walls were thicker, and I was able to apply a lot more force to them, that they would break apart pretty easily. So, I mean, these guys are pretty live, but I mean, with something that's on a much greater scale, that's when you start running into problems with not being able to perform mass damping in plants.